This is the logistic regression video on defining the outcome variable. Please recall that what makes logistic regression distinctive is that the outcome variable is dichotomous. In some cases, this dichotomous outcome is unequivocal and natural. For example, a surgery will either lead to a major complication or it won't. In other cases, the dichotomous outcome is formed by starting with a continuous variable and applying a cut point. For example, time of death could be collapsed into alive at 6 months or not. The results of a continuous reading of total cholesterol could be recoded into normal versus not. An ordinal quality life scale could be dichotomized by comparing excellent or very good versus good, fair, or poor. Composite outcomes simplify multiple outcome variables into a single quantity. For example, patients could be deemed to have improved if they exceed a cut point for any one of 5 physical functioning tests. To the previous examples, throw away information. For example, by considering vital status at 6 months, we no longer know the exact time of death, only whether or not it occurred within a certain period. Similarly, we no longer know the exact cholesterol level, only that it exceeded a particular cut point. The hope in dichotomizing an outcome is that you'll gain more in simplicity of analysis and reporting than you'll lose by discarding information. Dichotomizing a continuous outcome works perfectly well when the resultant classification has a natural interpretation. For example, if you're bit by a bat and develop rabies, you'll either die quickly or be cured. Surviving 30 days is the equivalent of being cured, and not surviving 30 days is equivalent to a rabies-induced fatality. If you die quickly, it doesn't much matter whether you live 6 days or 16. If you survive 30 days, you'll probably live for many more years. In this example, 30 days would not only be a natural cut point from the perspective of interpretation, but also be a natural break in the distribution of survival times. In contrast to the previous examples, composite outcomes combine rather than throw away information. They work best when you're combining likes with likes. For example, when you combine serious medical events such as death, MI, and stroke. Composite outcomes are potentially deceptive when you combine events of widely different levels of severity. For example, suppose that a personal care product prevents hangnails but has no impact on mortality. If your study has lots of hangnails, you might find that a composite out of death or hangnails is statistically significant. This doesn't mean that you should advise the tracutical repair kit saves lives. The last example in this slide is somewhere in between. The outcomes all pertain to similar constructs and are of roughly similar severity. On the other hand, they do combine objective and subjective measures. The principle of likes with likes isn't what's in question, but what isn't certain is whether the components of this particular composite outcome are sufficiently alike to count.